To find horizontal and oblique asymptotes, we have to divide, and we usually just take the highest power from the top and the highest power from the bottom and divide them. Now, notice that this is the graph of our function here. We get a vertical at x equals -3. We get a horizontal at y equals 0. Notice that when you divide x with x squared, you're still left with an x on bottom. Or in other words, x goes into 1 0 times. Your next example, you got 3x plus 4 being divided by x minus 2. This is what that function looks like. If we divide highest powers from top and bottom, 3x divided by x equals 3. Or in other words, we have a horizontal asymptote where y equals 3. In your next example, x squared plus 4x divided by x plus 3. Here's the graph of that function. Notice we have a vertical, but then we have this slanted one. This is called an oblique asymptote. We find this by dividing again. We've got x squared over x, which reduces to x, right? Which means we've got the x portion of our line. We need to find the constant portion of our line. To do that, you need to do long division. So reminder with long division. We have x plus 3 going into x squared plus 4x. We already divided the x squared by the x, and we got an answer of x. Now at this point, remember you're supposed to multiply the x to the x plus 3, and we get x squared plus 3x. And then you subtract. 4x minus 3x, that's 1x. Then we take this 1x, you divide it by the x, and you get an answer of 1. So we don't need to even finish the rest of the multiply, subtract, etc. All we need is the constant that goes with this. So x plus 1, this is your oblique asymptote. That is your line that goes down diagonally through here like this. So notice it still gets close to it, but it won't cross it on either side. That's your oblique asymptote. So here's the general rule for your horizontal or oblique asymptote. So again, you're going to divide the highest powers. So once you divide these two things right here, once you divide them, if you end up with an x that's still on the bottom of your fraction, or x squared or anything, if it has a variable down there, then you have a horizontal asymptote where y equals 0. If you divide those things and you end up with just numbers, there's no more variables at all, then you have a horizontal at that number. Y equals whatever number that is. If you divide these things and you end up with the variable on top or just the variable, then we've got to use long division to get the oblique asymptote, put it in y equals mx plus b form. Alright, so if we have this x plus 2 over x squared plus 5x plus 6, take these highest powers from top and bottom, x divided by x squared, that's 1 over x. Notice that that falls into the case of the first part where there's an x on the bottom. So we have a horizontal asymptote where y equals 0. When we had 3x plus 4, we divided these. 3x divided by x, we got 3, which falls into the second case. And so our horizontal asymptote was y equals 3. In the last case, we had x squared divided by x, which left us with a variable, which is the last case here. And we used long division to figure out that we had a oblique asymptote where y was equal to x plus 1. Again, so we just used all three of these to show each case. Alright, so if you have this one, 2x cubed plus x squared plus x plus 2, and you can divide that by x squared. So 2x cubed divided by x squared is 2x. Notice that we still have an x. So according to this last case, we still have an x. We've got to use long division to find the constant that goes with this. So I've got x squared minus 2x going into 2x cubed plus x squared plus x plus 2. I divided them already and I got 2x, so I'm going to put that up on top. Multiply that through the front, so we get 2x cubed minus 4x squared. Then we subtract. So these go away and you get x plus 4, or x squared plus 4x squared, that's 5x squared. Now don't just write this number, because sometimes you're not dividing just by x squared, it might be dividing by 3x squared. So we still got to divide the 5x squared over the x squared, which in this case is just 5, but it won't always just be this number depending on what you're dividing by here also. Which means this right here, 2x plus 5, is your oblique asymptote. I don't need to find anything else. Y is equal to 2x plus 5, that's your oblique asymptote. You will now have time to work on your assignment from 3.3.